Hello everyone, this is the 15 video from the DP series. The problem that we are going to solve that is increasing subsequence. You are given an array containing an integer. Your task is to determine the longest increasing subsequence in the array. Okay, so you have array of length n. You have to find the LIS, that is longest increasing subsequence. So let first understand what is subsequence. Subsequence. The definition is given that a subsequence is a sequence that can be derived from the array by deleting some elements without changing the order of the remaining elements. So you can achieve it by deleting some elements, right, from the array, but order has to maintain. So some of you have a doubt that between subarray and subsequence. Subarray, that is contiguous. Subsequence need not to be contiguous. Right? Subarray has to be contiguous. Need not to be subsequence need not to be contiguous. Right. So suppose you have elements 7 3 5 3 6 2 9 8. Right. So the subarray would be 7 7 7 7 3 7 3 5 7 3 5 3 7 3. Right. These are subarrays, but subsequence can be 7 5 6 7 5 2 7 3 9 7 2 8. Right. So subarray subarray has to be contiguous. Subsequence need not to be contiguous, but it has to maintain order. That if you take 7 5, you cannot take 3. Right. You cannot take 3. Right. So you have to maintain order. That is 7 5 6 9 8, something like that. You cannot take 7 3 then 3 then 6 then 9 then 6. That is something that you cannot do. So you have to find the longest increasing subsequence. You have to find the longest increasing subsequence. Now, what is the increasing subsequence? For the increasing subsequence, uh, every element is larger than the previous element, right? So for every element, for all element, uh, right? For every element, it has to be larger than the previous element, right? It has to be larger than the previous element. So let's understand it with example. 7 3 5 3 6 2 9 8. So you have 7 3. Let's find out the long increasing subsequence. That can be 7. Then you can take 9, right? Then you can take 9. Can you take then 8? No, because every element uh, is has to be larger than the previous one, right? So 7 9. Then you cannot take 8 because it is smaller than the 9. So 7 9 7 8 can be the sequence of length 2, right? Now, if you start with a 3, you can take 5, you can take 6, you can take 9, you can take 5, you can take 6, you can take 8. So this has a length of 4, this is a length of 4, and this is the longest one. This is the longest one, right? So the length of the longest increasing subsequence for this array is 4. Okay, fine. Now we have to find, let's try to get the intuition how we are going to solve it. Now, let's suppose start with a 7. Start with the 7 very first element. What could be the length of the longest increasing subsequence if you have the element only 7? So for this, the length is 1. For this, the length is 1, right? So for this, the length is 1. Now, try to take 3. Can you have 7. Can you place 3 right here? No, because it does not greater than the 7, right? You have to make it increasing, right? So 3, you cannot add 3. Now, for this, there is only one, for if you start with element 3, so there is only one longest increasing subsequence, that is 3 itself. So for this, the answer is 3. Now, can you add 7? If you start with a 7, if you have the element 5, can you add 5? No. So for this, the length is also right. Now, 1 second. Can you add 3? Can you add 5 if you start with a 3? Yes, you can. So you take the element and you try to place it next to the previous element. So you cannot place. You can place. So you can place. So up for 3, what are the subsequence? what are the longest subsequence that you can have? That is of length 1. So for 3, you have the longest increasing subsequence of length 1. Now you can add one more. So for this, the length should be 2, right? Perfect. Now let's try to do with this. You can add no, you can add no, because it has to be greater, not greater or equal. You can place no. So there is only one subsequence, that is the element itself, right? Can you place 6? No. Can you place 6? Yes, you can place. So for 3, there is only one, there is only length, there is only subsequence of length 1, right? So you place it, you can place the 6 after the 3. So you can add one more. So for this, the answer is 2. Now for say for 5, can you add? Can you add? Yes, you can. You can add 6 next to the 5. Now for 5, there is length of the subsequence of 2, that is 3, 5. Now you add one more. So for this, you have the length of 2. Now you add 6, one more. So for this has to be 3. So what you do? You try to add from the previous one, right? You have the next element and try to place it and try to place it. If you can place, then you find then suppose for x element you can place the next element. So you found that what is the longest subsequence that you can make with the x, and you can place the next one. So you have to add one more. So suppose dp of you maintain the dp array, and dp of I represent for the index I. For index I, what is the lis? What is the for the index I? What is the longest increasing subsequence? Right? Then you traverse from then you take uh, then you try to place the previous can be from 1 to I minus 1, right? And if if you can place I, that is if that is suppose this is the array. If AI, one second, let me take it. Yes. So if previous is if AI is greater than the previous, then you can place it. Then you can place it. Then you update your state that dp of I is equals to dp of j plus 1, right? dp of j plus 1, right? So now let's do for the 2. You have the element that is AI, and you have the previous that is from this to this. So you try to place it. You can place no, you can place no, you can place no, you can place no, you can place no. So you initialize your DP array with 1, right? So you can initialize your DP array with 1. This is something that is DP array, right? Now try to place 9. Can you place? Yes. Yes, you can place because AI is greater than the previous. So what is the DP of I? DP of I is the how many what is the length of the longest subsequence for for the element 7, that is of length 1. Then you add one more. So for this the length should be 2. Now can you place 3 to 9? Yes, you can place. And if you try to place, if you place it, right, if you place it uh, 3 with 9. So 1 plus uh, 1 plus uh, 1 plus 1, that is 2. So this is already 2, right? So you are not updating it, right? And you are updating it. That is suppose you are updating it with 2. Now can you place 5? Yes, you can place. Yes, you can place. Now for 5, you have the length of 2, right? You have the length of 2. So you take the 9 also. So 3, 5, 9. This is one of the possible longest increasing subsequence. So of length 3. So you update it with 3. Now can you place 3 with 9? Yes, you can place. But you can see that if you try to add one more, So this is something that you can notice. So you have to take the maximum of dp of I and j plus 1. What is the maximum, right? You have to update it with maximum. So you have to take the maximum of dp of I and dp of j plus 1. Now you cannot, you do not update it with, because you have the maximum of 3. That gives you 2. Now for 6, can you, uh, for 6 you have the length of 3, right? That is 3, 5, 6. Now you add one more 9. So for 6, the length is 3. So you add one more, that's 4. So 3, 4, maximum is 4. So you're going to update it with 4, right? Now can you add, uh, 2 to 9? Yes, but this gives you the length of 2. We have the already maximum length of 4. So we take the maximum of 4, 2, that is 2. So for similarly for 2, for 8, you can do it. First update it with 2, then update it with 2, then 8, 5, update it with 3, then 8, 3, update it with the maximum of 2, comma 3, that is 3. Now 3, you got the 2, you have the maximum of 3. For 6, you got the 4. So you update it with 4, right? That you can see that this tool and subsequence is because of 3, 5, 6, 8 and 3, 5, 3, 5, 6, 9, right? So whatever the maximum answer that you can get from this, right, from DP, you have to find the maximum. So you can, you have to, for all of these, you have to take the maximum, right? You have to take the maximum. So maximum is 4, right? So whatever the answer, whatever the maximum, this is going to be your answer. Now one thing, uh, so this is work, but this, the time complexity of this is going to be n square, right? N square. This is something very slow, right? For n equals to 2 into 10 to the power 5. In the worst case, the n can be 2 into 10 to the power 5, and the time complexity is n square. So for this, the this is something very slow. So we have to find out optimized approach, right? So let's try to optimize it. So let's try to optimize it. Suppose you are trying to make the increasing LIS, longest increasing subsequence. So you start with the element, very first element, that is 7. Can you put 7 into the sequence? Yes, you can put. So you can put 7 in this sequence. Now the next element is 3. Can you place 3 next to 7? No, you cannot, right? So the next element is 5. Can you place 5 next to 7? No, you cannot. But wait, you found previously 3, right? So if you replace 7 with 3, if you replace 7 with 3, you are able to add 5 in your sequence. Then the length of the sequence would be 2. And if you note, the length of the sequence would be 1, right? So what do you observe? That if you found minimum, if there is some minimum number that you have, then you have to replace it. Then you have to replace it, replace it, right? Then you have to replace it. So if you replace 7, so why it is work? That there is some, if you not replace it, you lost that, uh, you lost the longer one, right? What I mean to say that if you do not replace 7 with 3, you are not able to, you are not able to make the longer LIS. Why? Because in future there is some element that is lesser than the 7 but greater than the 3, right? That is 5. If you not replace it, so it is greater than the 3 but lesser than the 7. So this is something that you could observe. And by this observation, I replace 7 with 3, and I able to make the LIS of sequence of length 2. Right? Perfect. Now the next element is 3. Are you able to uh, put 3 next to 5? No, you are not. Now this is minimum, and this is minimum. Right? You found minimum. Now let's go further. I take this case later. Right? Uh, I take this case later. So the next is 6. Are you able to put 6? Yes, you can able to put 6. So next thing that you have to observe that if ending element uh, is greater than the element, right? Or I would say that element of the array greater than I would say that the current element, right? Greater than the current element, then I would definitely add it into sequence. Then you have to add it, right? Then you have to add it. This is the next observation that I could make, that is this. Now, this is something, now the current sequence is this, which of length 3, right? Now the next number is 2. The next number is 2, right? The next number is 2. So are you able to put 6? Are you able to do? No. So this is something you found minimum. So till previously you found minimum 3, then you found minimum 2. So let's try to place 2. In the first case, you are easily able to replace 7 with 3 because there is only one element. But if there are multiple elements, right? If there are multiple elements, you could not replace it with the last element because it it doesn't maintain the increasing sequence always. It doesn't maintain the increasing sequence, right? Suppose you add 2 at the last. So this is not the increasing sequence, right? So you have to maintain the increasing sequence. You have to replace it with, you have to replace it with such that the increasing sequence maintains. Increasing sequence maintains. Increasing sequence maintains, right? You have to replace it with. Why would you not add, right? You could add 2 here, right? That would maintain the increasing sequence. So why would you not add? You do not add, right? You have to replace because minimum 1 does not helps you to make the longer sequence, right? Minimum 1 does not help you to make the longer sequence. The greater element is helps, right? The greater element helps you to make the longer sequence. Minimum 1 does not, right? So you have to replace it with, right? Now, how would you replace? What would be the correct position of the two? You have to find out that. You have to find out that. You can replace at one position, at zero position, at one position, at two position, right? So what could be the correct index for the element 2? It would be, then you have to iterate again, right? To find out the correct position or correct index, you have to iterate again. So this would result again n square complexity, right? This would result again n square complexity, right? There is something that we can do, that we have to maintain the increasing sequence and we have to find the such that we have to find the correct index. So this would be the, if you replace it with first greater or equal element index, if you find the index of the first greater or equal element and you replace it with that index, this would definitely maintains the increasing sequence, right? Why? You found the first greater element of 2 is 3 and the index of this is 0. So you replace it with 6. So this is uh, the increasing sequence. If you replace it with it, uh, it is increasing sequence, right? Now, if you replace it, now let's see the next. Now let's try to replace 3. So at this point, you have to replace 3, right? So you have 3. You have to add 3. You cannot. So you have to replace with some in some position in the sequence such that increasing sequence maintain. So you found the first greater or equal, which is 3 itself. So the sequence remains the same. You replace 3 with 3, right? So this is something which is helps, right? How could you find the first greater or equal? Binary search, binary search, or in C++, we have the function. lower bound, right? Lower bound. So this would result uh, log n complexity, and we iterate all over the n. So the total time complexity would be n log n, right? So this is how uh, we can optimize it. Okay, perfect. Now let's complete that. Now let's complete the iterations. So we are at the 356, right? And we replace it 3 with 2. Then we have 9. We definitely add it, right? 6, 9. And we definitely replace 9 with 8, right? Because this is the first greater element. 8 is the minimum, and then we have to find the first greater element. That is the lower bound of 9 is 8 is 9. So we have to replace it with. Now the the intuition is that we why we replace that in future there is some greater element, there is some greater element than 9, uh, there is some greater element than 8 which is lesser than 9, right? There is some greater element than 9 but which is lesser than 8. So if I do not replace it, I lose it, right? I am not able to make the longer increasing subsequence, longer increasing subsequence, right? So this is what that I can do. Now this is, you notice that this is not the uh, actual increasing LIS, because you found that 2 comes up. Uh, we saw that the we saw that increasing subsequence is that which maintains the order. So this doesn't maintain the order. 2 comes first, 5 comes 5 comes first, 2 comes later. But in the sequence, 2 comes first, 5 comes later. So this gives you the size, not the actual subsequence. So this gives the size. So whatever the size of this array, this is our answer. That is 4. Right. So now let's try to see. Now let's try to write the pseudocode. We maintain the DP array, and we iterate from 1 to n, and we found the lower bound. We found the index. Suppose we found the position is equals to lower bound in DP array of the element. Suppose element, right? Or I would say current element. I write it with current element. And if the position is equals to dp dot size, what it means that uh, there is no such lower bound, right? There is no such lower bound, which means that uh, we have to add it. So dp dot add that element. Else, what we have to do? Else, we have to add replace it, right? At this position. So at this position, we have to replace in our subsequence, that is with this element, right? At the end, our answer is equals to dp dot size. So this is the pseudocode, right? So this is the code. So I hope you got the intuition, you understood it, and if it is not, comment it down. Now let's see the code, right? Now let's see the actual code. Let's code it. We have the length of the array n, right? And define the array of length n, take the input. This is the input. Next, we have to define the tutor, right? So, and then we have to iterate from I equals to 0, y less than n, a plus plus, int cur equals to a of I, right? This is the current element. Then what we have to do? We have to find lower bound, right? So let's find the iterator. lower bound, a dot dp dot begin, start dp dot end, and we have to find the lower bound of cur. Right. Now, if it is equals to dp dot end, then there is no lower bound. Then we have to add it into our dp array, dp dot pushback, dp dot pushback cur. Else we have to replace. So we have to replace. So else I star it equals to cur. Right. Else we have to replace. And finally we have to print dp dot size. And yes, so this is the code. Perfect. Yes, great. Let's try to run it. Yeah, it gives correct answer, that is a length of 4. Right. So the time complexity of this code is n log n. Right. This is the code. I hope you understood it. If it is not, comment it down. I try to resolve your doubts. Thank you.
Until we reach it, all you need to know is that we're holding on. We rise up from